Hey everyone, today I want to share something I'm super excited about, the new materials space. Now I know materials science might not sound like the flashiest topic, but trust me, there's some really cool stuff happening right now that's changing entire industries. Let me tell you why this is going to be a big part of what we're going to do next year. I'm also going to talk briefly about what we're skeptical about. First off, we're seeing amazing breakthroughs thanks to interdisciplinary research. This is where materials science meets fields like biotechnology, chemistry, and even physics. It's not just about scientists working in silos on their own anymore. It's about collaboration across disciplines. Imagine biologists working hand in hand with material scientists to create new materials using fermentation methods, or chemists teaming with engineers to develop super strong, lightweight composites. Now, when we look at deep tech startups, we look for expertise across multiple disciplines. Maybe the CTO is a PhD in material science, but they may also have a biologist on the team or as a key advisor. And then there's nanotechnology. The idea of nanotech has been around since the 1980s, but we're seeing a lot of that research paying off now. We're talking about things like materials that can repair themselves, or fabrics that can change color on command, or nano coatings that you can spray on materials to improve their performance. Responsive and smart materials are another exciting frontier. These are materials that can change their properties in response to their environment. Things like built-in sensors, actuators, or even materials that can change shape. Imagine a building that can adjust its structure to withstand an earthquake, or clothing that can adapt to your body temperature. Another area that's really heating up is advanced manufacturing techniques. Think 3D printing, additive manufacturing, and composites. These aren't just new ways to make things. They're opening up entirely new possibilities for what we can make. We're talking about creating complex structures that would be impossible with traditional methods, or using less materials to achieve the same or even better results. This is not just about efficiency, it's about pushing the boundaries of what's possible. Now, let's talk about AI and quantum computing. And you're going to ask, why does this fit with new materials? These are accelerators for materials research and development. AI is helping us discover and develop new materials faster than ever before by predicting properties and simulating how different materials will behave under various conditions. And quantum computing, well, that's taking things to a whole new level, allowing us to tackle complex, multivariate problems that were almost impossible to solve using existing computing methods. The speed and accuracy with which we can now innovate in materials science can be absolutely game-changing. Every time I talk to a materials startup these days, I ask what their software strategy is. And of course, we can't talk about the future without addressing sustainability. Circularity is becoming a key focus. One thing we're seeing is become more economically feasible to get value from waste, for instance, recycling into similar materials or upcycling into new materials. But the other big change is that the developers of new materials are now looking at the full life cycle of the material. So demand for circularity in materials is coming from two places. One is regulations, especially in the EU, are forcing companies to get transparency and take full responsibility for the source of their materials and the full life cycle of them. The second is become more profitable to take a sustainable approach, partly because new generations of consumers are paying a premium for it. Carbon credits are helping with the economics, and also next generation technologies and manufacturing techniques are improving the efficiency and yield for sustainable materials, recycling, and upcycling. So it's now making a lot more economic sense. So there you have it. The new materials space is where science, technology, and sustainability intersect. And I believe it's going to be a major driver of innovation in the coming years. Whether it's creating smart, stronger, or more sustainable materials, the possibility is endless. That's why I'm super excited to be investing in this space. Now here's the but. First, the data shows that new materials, like any deep tech, have great investment return potential, and the exit horizons are not that different from other venture capital categories. However, new materials are not something you can go to market with an MVP and immediately get immediate feedback from users. Because of the long development cycles before commercialization, we need to have some confidence that there's a market and that the market will readily use these new materials. Just like with any technology investment, there's probably going to be more failures than successes. So I'd like to be able to share more on this soon and with some examples. But for now, in a nutshell, here's some ways we look at it. First, we want to understand the potential performance and functionality of the material compared to what it's replacing. The sooner we can get data on this, the better. It may be about durability or purity levels. Sometimes it's even about color or even smell. For instance, how well would a thin film bioplastic that's made from fish scale waste do as a food packaging material if it still smells like fish? Along with that, we want to get a sense for the unit economics compared to what it's replacing. At scale, is it comparable or would it need to be sold at a 10x premium price? The whole cost structure matters, such as the raw materials cost, transportation cost, cost of additional chemicals for cleaning and treatment, and so on. Everything matters. Third is how easy this new material can fit into existing supply chains and production processes. Do you need to actually have a vertically integrated product and sell it as an end product for this to be successful at all? Or can you take this material as and make it a drop-in replacement for something that already exists? Together, these tell us about the size of the market. Is it a niche market because it has limited application, high cost, or if it's comparable and or cheaper and can be in a drop-in replacement for existing materials? These are very, very different things. Niche versus major market. Of course, we also look at things like the team, the competitive dynamics, the IP, and so on. And we're always working with incomplete information early on, but some of these things we try to look at as soon as possible and get data where we can to mitigate risk and take a smart bet early on and know that maybe we're going to avoid an entire category because that category doesn't check the boxes that I just talked about. So I hope you enjoyed this look at new materials in our series of what we're excited about at DeepTech. Look forward to seeing your comments and questions in the chat. Thank you very much.